In this video, let's check how to draw an epicycloid. The question would be: a circle of 50 mm diameter rolls on the circumference of another circle of 175 mm diameter and outside it. Trace the locus of a point on the circumference of the rolling circle for one complete revolution and name the curve. So here some points are highlighted where it is given a circle of 50 mm diameter. Circle of 50 mm diameter rolls over the circumference of another circle. So 50 mm diameter circle rolls over such kind of circle is known as the generating circle, and it rolls over circumference of another circle. So such kind of bigger circle is known as the directing circle, and it is mentioned as the circle rolls outside it. So whenever it is rolling outside it, it is known as the epicycloid. If in the question it is given as the circle rolls inside it, then it becomes hypocycloid. Let's check about the epicycloid. The definition is given at the top. Epicycloid means when a circle rolls on a directing circle without slipping, the curve traced by a point on the circumference of the circle is known as epicycloid. When a circle rolls, it is given red color, so the rolling circle is known as the generating circle, and the bigger circle over which the generating circle rolls is known as the directing circle. It is given as the generating circle is of 50 mm diameter, therefore the radius is 25 mm, hence small r is 25 mm, and the directing circle diameter is given as 175 mm, and therefore capital R is 87.5 mm. It is 175 divided by 2, 87.5 mm. Now we have small r 25 mm and capital R 87.5 mm. First we have to draw a straight line, and here capital D and 0 is of length 87.5 mm, and then D0 is further extended up to capital G, where 0G is of 25 mm. With D as center and radius D0, an arc is drawn in deep blue color which denotes the base circle, which is the radius of the directing circle, and then with the D as center and radius D capital G, another arc is drawn which denotes the locus of the center. An arc has to be cut and angle theta has to be subtended. So to do this, how much angle has to be subtended? Calculations are done as given here. The formula is theta by 360 equal to capital L by 2 pi capital R, where capital L denotes the circumference of the generating circle or the rolling circle. So the circumference of generating circle is 2 pi small r divided by circumference of the bigger circle or the directing circle is 2 pi capital R. Here 2 pi gets cancelled. We are left with smaller by capital R. So theta is equal to smaller by capital R into 360, which is 25 divided by 87.5 into 360 in this particular case, and we get this as 102.8. Now with a protractor, here the red color theta 102.8 is cut off and a line is drawn. This line cuts the arc at the point. That point is marked as 8. We have the base points 0 and 8. Now this angle 102.8, that is the angle between 0 capital D and 8. This angle 0D8 is bisected to get the point 4. Now 0D and 4, the angle is bisected to get the point 2. 0D2 is further bisected to get the point 1. Same procedure is followed between 2D4 to get the point 3. Now 4 to 8, that angle is bisected to get the point 6. 4D and 6 is again further bisected to get the point 5. 6, D and 8 is bisected to get the point 7. Now these lines are extended till the black arc, which is the locus of the center, and on extension we get the center points C1, C2, C3, C4, C5, C6, C7 and C8. The center points are marked in black color. Now with G as center, G0 as radius, in this case G0 is 25 mm, so with radius 25 mm and capital G as center, we draw the circle denoting the generating circle. This generating circle is divided into 8 parts. The division is already shown in the video of cycloid. Now these 8 parts on the generating circle are numbered from 1, 2, 3, 4, 5, 6, 7, and the eighth point coincides with 0. These points are shown in red color. They are the generating points. The points on the generating circle are known as the generating points. Now with capital D as center and radius D and generating point 7, we draw an arc. This arc at the end we write 1, 7. This arc denotes locus of 1, 7. Now with capital D as center and radius D, generating point 6, another arc is drawn denoting that arc passes through the generating points 6 and 2, and this denotes the locus of 2, 6. What we need to observe here is the locus of 2, 6 does not coincide with locus of the centers. But in plane cycloid, in the normal cycloid, the locus of 2, 6 coincides with the center locus of the center. But in epicycloid or in hypocycloid, the locus of 2, 6 does not coincide with the locus of the centers. Now with D as center and radius is D and generating point 5, an arc is drawn. This arc denotes the locus of 3, 5 because this arc also passes through the generating point 3. Now with D as center, radius equal to D and generating point 4. Here the radius would be D to generating point 4, that is 87.5 plus 50 mm. With D4 arc is drawn, and at the end in brackets 4 is mentioned to mention it is the locus of the point 4. Now C1 as the center, we have to cut an arc on the arc 1, 7, and the point is marked as P1. With C2 as the center, an arc is cut on the locus of 2, 6 and the point is marked as P2. With C3 as the center, an arc is cut on the locus of 3, 5 and the point is marked as P3. With C4 as center, an arc is cut on the locus of 4 and the point is marked as P4. With C5 as center, an arc is cut on the locus of 3, 5 and the point is marked as P5. Similar procedure is carried to get the point P6, and with C7 as the center, arc is cut on the locus of 1, 7 to get the point P7, and finally we have the point 8 which coincides, which is also P8. Now that we have the points 0, P1, P2, P3, P4, P5, P6, P7 and P8, a freehand curve is drawn to pass through all these points, and such kind of curve is known as the epicycloid. To get the normal and the tangent, let's see the question here. It is given as draw a tangent and a normal to the curve at a point 125 mm from the center of the directing circle. Center of the directing circle is capital D. So with capital D as the center and radius 125 mm, an arc is drawn to cut this epicycloid. So here with center D, an arc is drawn to cut this epicycloid, and the point is marked as P. Now with P, we need to find its corresponding center on the locus of the center, that is on the black color arc. So with P as center and radius equal to 25 mm, we need to cut an arc on the locus of centers, and this arc of radius 25 mm cutting the locus of the centers, that point is marked as CP, which is the corresponding center point. Now the joining CP with the capital D, we get a line that will be cutting the base circle at a point between, in this case, 5 and 6, and this point is marked as PB, base point. This base point is joined with the point P on the epicycloid to get the normal, and another line is drawn perpendicular to this normal passing through the point P. That line is known as the tangent. Now this particular slide gives the complete steps by which we can draw the epicycloid. So in this way we can draw the epicycloid and also the normal and tangent. Now coming to the hypocycloid, here what we see in epicycloid is D0 is extended, and then 0G is of 25 mm through which the black circle is drawn. Now in hypocycloid, the D0 is not further extended, but from 0, 25 mm is drawn towards the point capital D, and the point capital G is marked. So capital G will be somewhere in between 0 and D, such that 0 capital G is 25 mm, and then the remaining procedure is same as that of the epicycloid.